of spring 2025. Thank you for attending all semester. Attendance has been great, especially today. I've never seen so many darn people here for DLS. This is wonderful. So this is the last DLS for the semester. It's a special DLS in that it's a little bit different than the typical format. It's being led by a group of students who are learning a broad class with Banshee in Taiwan. And a couple quick announcements before we start with the main guest today. The first is there's a couple important events taking place next week. One is the poster session. I'm sure that's on your radar, as well as the awards banquet. So make sure that those aren't, if you're around, those are good events to attend. Other than that, I think Juan Carlos.
Yeah, I just want to give a thank you to Chad and the staff to putting DLS together this year. I think it was a great year of DLS, and let's just thank Chad for putting everything together.
So at 1:30, the torch gets passed to Saku and Sarah. Awesome. With that, I'm going to hand it off to Banshee to introduce the players.
Okay, welcome everybody. I guess let's choose one more seat. Wow, you guys want to see here. Yeah. Okay, so thanks for coming. So I guess it's about the COVID times in Taiwan. I was like, they are sabbatical and stuck there for a couple of years. And I was thinking like, wow, it would be great to have an opportunity to bring students to Taiwan and visit all the active tectonics and the geology. And when I come back and I teach the one session in the field, I told students, well, I do a quick survey whether it would be interesting in this. And they overwhelmingly think it would be a good idea. And some of the students, I'm glad I got a chance to offer this before they graduate. So they actually kind of participate in the trip. And I think we have a wonderful time. So you can see this is like a picture we took. Taiwan is just sitting right on the boundary between Eurasia plate and the Philippine Sea plate. So we actually was able to stand right on top of the bridge. You can actually see it, like they crack a little bit due to the displacement of the two plates. But student will talk more about it. And before I pass down to the student talk most of it, I just want to quickly kind of like summarize it. We actually have 8 undergrad students, 8 grad students participate in the trip. But additional to that, we actually have 13 Taiwanese students from 3 different universities also participate in the trip, which have a good turnout basically. And I want to quickly acknowledge that the trip won't be able to be possible without the support we got. So we got a lot of support. In particular, the Department of Geoscience from National Taiwan University, they help us to book all the logistics, like buses, hotel, and everything. So big thanks to them. We have 7 faculty members on the Taiwan side, from different academic institutes, all come out to help. They are super eager to talk to students from Utah. So it's great to have them in the field. Like this is one example, Vivian Chow from Chiao Tung University, who come out, talk to us about their research in this area. And we also visit 3 national museums. And in Taiwan, the museum actually have 1 day off every week. And somehow we always choose the day they're out to visit them. And they graciously, I twist some arms to make that happen. They all open up, and so we were able to visit them. So it's a great thing to have. And we also visit 2 national centers, and then 1 geotechnical company actually come out and talk to us about their project. And lastly, we got financial support and staff support from our department as well as Learning Abroad. So Max here from Learning Abroad actually helped us to put this together. So big thanks to Max. So with that, I'm going to turn this to students and let them show you what they learned, and then you judge yourself whether this is a success or not.
Hi everyone, my name is Ivan. This has been 30 minutes on the trip, and my goal today is getting to explain why Taiwan, why is this an exciting environment. So as Banshee mentioned, we're at the Eurasian and the Philippine Sea Plate. We're seeing a convergence rate of about 80 millimeters a year, which is pretty fast. It's about twice the growth of your fingernails per scale. And we're seeing just great tectonic activity. The central mountain range experiences incredible uplift, and in the longitudinal valley, we see the Okinawa Trough, which is just a trough. So lots of things to explore here. There's also a bunch of uplift, erosion, and landscapes. Again, Central Mountain Range has these beautiful mountains, just incredible scales. And this leads often to steep landscapes that can result in a lot of sediment flux and landslide activity, especially with the amount of rainfall that we're seeing, which is equivalent to like 3,000 millimeters a year on scale, which is a lot of rain. So we're seeing a bunch of tectonic activity, a bunch of erosional features, and just this changing landscape that we want to explore. And a whole bunch of geophysical techniques are being used to explore this landscape. I'll talk a little bit about INSAR, since it's what I'm most familiar with. It's interferometric synthetic aperture radar using satellites in the sky, provided to us by whoever does satellite stuff. We're able to compare different radar wavelengths on different days and look at the surface deformation. This really helps us with earthquake events such as the 1999 Chichi earthquake, where we're seeing just a huge landscape change on the surface, and we're able to see the compression and extension of the plate using radar technology and other geophysical techniques. And again, it's a rapidly changing landscape, so we want to understand as students and faculty why Taiwan matters on the larger scale and how we can adapt to these geological changes. So I'll pass it on to Lux.
Thank you, Holly. So as you guys could probably already glean from Yvonne's beginning of the lecture, Taiwan has a lot of geological vulnerabilities. We also have a lot of social vulnerabilities. So Taiwan is 36,000 kilometers squared, about 400 kilometers from north to south, which in American terms is a little less than 250 miles, and about 100 kilometers from east to west. I forgot how many miles that is, but not a lot. In comparison to this, Utah is 220,000 kilometers squared, so quite a big difference. In addition to this, Taiwan has 23.5 million people compared to our 3.5 million people. So you can start to get an image of how many people are in this little island. And then, on top of this, nearly 2/3 of the population live in these really highly populated urban areas because, as you can see from this population map, the central mountain range right here is really steep, is prone to a lot of landslides, and so it's not very livable. Okay, so then with most people crowded in these big cities where there's a lot of infrastructure and a lot of technological innovations occurring, that leads to Taiwan being the third most extreme country for absolute economic exposure in the world, which is kind of insane. But so if you think about that, then you think about in another ranking, they were actually ranked with incredible disaster resilience, so that they are actually one of the lowest risk countries for disasters. How can this be? One of the biggest things, I forgot my words. One of the biggest contributors to this is the National Science and Technology Center for Disaster Reduction, which is this amazing corporation that goes around and helps Taiwan to be more resilient to the different disasters that we face. And they have 3 different things that I'd like to outline that help them out with this. The first is technological applications, specifically emergency responses and education. They're really good at getting a lot of educational sources out to people, especially to communities that have disabilities. They're very good at making this information accessible, and they make really cute mascots to tell people when disasters are happening. So I think that's very eye-catching for sure. The second one is something I'm very interested in, is this website called Transparent Risk, which is a transparent risk map For landslides, debris flows, flood risks around the country, they show the riskiest sites to houses and to buildings. And something really interesting about this is that construction companies used to hate this website because they were like, you guys are lowering our property values by telling people that it's unsafe to live here. But over the years, they've actually learned to collaborate with NCDR and collaborate with these maps to build their houses in safer areas and use these maps as advertisements to show, hey, our houses are safe. This is why you should buy where we're developing. So that's really interesting, and that leads into the third most important thing, which is private sector collaboration. They're really good at this. They're really good at combining NGOs and academia's communities who are usually the first responders to these emergency situations. And in addition to this, international cooperation is huge. So they cooperate with other really high-risk countries like Japan and the US. They go out to our countries and they look at our own techniques that we've been doing to mitigate hazards. They take those, export them back to Taiwan, change them up for their own specific geomorphologies, and then make their own new systems and actually export that knowledge back out to other countries that are developing their own hazard mitigations. So I think that's really cool. It's this whole network of people that are constantly learning from each other and developing things to become a safer country. And then this was us saying hi to them. Okay. So next, I'll pass it on to Megan.
So we began our tour of Taiwan up in the north near Taipei, and then we first traveled down the west coast. Oops. So we started with Tactonic Volcano Group, which is up here in the north of the island. This is Taipei Basin, where a lot of the population lives, and it's the capital city. So these volcanoes are actually really close, only tens of kilometers away from the city. And this is us there, and that's what it would look like if it weren't foggy. So these are actually andesitic stratovolcanoes in Tactonic Volcano Group. There's not been activity in recent memory, but the most recent eruption was actually about 6,000 years ago. As you can see traced out here, this is the Sanchow Fault that runs through that area, and it's actually a major fault that runs through the Taipei Basin as well. It used to be a reverse fault due to the collision of Taiwan, but due to more recent geologically rollback of the Philippine Sea Plate, there's actually now an extensional regime in northern Taiwan specifically. So this is now a normal fault. Since this volcano group is considered active still, there's a lot of monitoring that goes on, including seismic monitoring, infrasound monitoring, CO2 monitoring, geothermal temperature monitoring, and also geodetic surveys for the deformation. So using seismic tomography, they've actually mapped out the magma chamber to be about 8 to 20 kilometers depth beneath the surface. And they do record roughly 1,000 to 2,000 microseismic events per month at this volcano group, which is quite a lot. There are also 6 explosive craters of some past activity at the volcano group, and there's fumaroles and gas escape that happens in a lot of different places over this volcano group. And this is us at one of the places where you have lots of bubbling water. And actually, following the 2024 Hualien earthquake out on the northeast coast of Taiwan, they recorded a seismic heartbeat, an 18-minute seismic heartbeat, where roughly every 18 minutes they would get this seismic signal. And they believed that it was due to rockfall that was caused by the earthquake, blocking the gas escape in one of these the vents in the volcano. And so every 18 minutes, the rocks would kind of bounce and let the gas out. But then after about 3 days, they believed the rocks broke up enough that they no longer recorded this signal.
Okay, next we went to this geopark. I think this is really cool because it is a direct parallel to things we see here in Utah. You can see the canoes here. They are part of the Dalian Formation, which is a calcium-rich sandstone, and the differential weathering comes from these richer layers of richer calcium. Sorry, the hoodoos mainly come from the monsoon and wind abrasion. And one of the most interesting things that we see here is these beds actually dipping, which is not something we really saw elsewhere in Taiwan because it is so highly vegetated. You just really can't see structures like that. And this is, over there is the Queen's Head Hoodoo, which is kind of like an icon for Taiwan. So it looks like a queen's head. And some of we were able to see a few marine fossils like sand dollars. And this is just a fun picture because there were some joint sets here of some of us in the structure class pointing out the principal stresses.
So, as has been mentioned, there's a lot of convergence going on in Taiwan, and this has led to a lot of reverse faults, as you can see in this animation from the Philippine Sea Plate converging with the Eurasian Plate. Excellent. And so this is a great hazard to Taiwan, as Lux pointed out earlier. And so actually in 1999, on September 21st, they had a 7.6 magnitude earthquake known as the Chi-Chi earthquake. It occurred at 1:47 a.m., fortunately, as will be brought out later. But it was about 100 kilometers of rupture on the central west side of Taiwan, which is highly densely populated. There was about 13,000 aftershocks to this earthquake. And this 100 kilometers of rupture, just for comparison, is comparable to the Salt Lake City and Provo segments of the Wasatch Fault combined. So pretty decent rupture size. But actually, if you think about the recent Myanmar earthquake that had about 500 kilometers of rupture and was also a 7.7, roughly, this is a lot less rupture distance for similar magnitude earthquake, so probably a deeper structure on this fault. But this was actually the biggest earthquake disaster in a long time in Taiwan, and was the second deadliest in Taiwanese history, going back to the 1935 earthquake that they had. Unfortunately, there were 2,400 people killed and over 11,000 injured in this earthquake, and tens of thousands of buildings were damaged and destroyed. And actually 132 landslides as well, so it was a pretty significant earthquake.
So the next kind of stop we went to was the dam, and this is right on the Chalongpu Fault, which is the fault that ruptured, and it actually went right through this dam, which is quite interesting. And they have preserved where this offset was just for educational, information. And because of the rupture, there is sediment filling in the reservoir, which is unfortunate, and they do have to dredge it quite often because it still serves 5 million people in this area. And another thing that they kind of have to do is there is now a waterfall that is encroaching on the dam, which is up here. And so here are some of the things that they've tried to engineer to prevent that, like putting big stone structures to kind of keep the waterfall in place. The next thing that we visited was the 921 Earthquake Museum. 921 stands for the date that the Chi-Chi earthquake happened. So back in the 1960s, Taiwan only had primary education, and after that they said we should do middle school. So all of a sudden they had to build all of these middle schools to accommodate all of these middle schoolers. However, that meant that they did it kind of poorly and very quickly. So that meant putting beams very far apart, having very wide windows. So when the earthquake hit, about 300 schools were destroyed. However, it's very fortunate that the Chi-Chi earthquake happened at 1 a.m. because that meant nobody was in them. If this weren't the case, probably a lot of people would have died. You can see that this was 3 floors at one point, just smushed. So the reason that this site was preserved, it was a middle school, is because the Chalongpu Fault runs directly through it. So the fault scarp would be right here, running through this building. And this is another picture of the fault scarp. You've probably seen it in textbooks because it is very well preserved, having the track run right over it. Yeah. And this is a picture of us in front of the class building. It's very important site, just for education, because it was a great tragedy that they want to commemorate and really educate people on why hazard prevention and engineering is important.
Okay, so we're getting into final site that we visited. It's worth spending 30 seconds just to understand paleoseismic trenching. So it's basically when you have a fault line, right, and you actually just dig a trench around this fault line. And what it means is that you can actually begin to understand how the sedimentary strata and the features that you see over there, such as faults and folds, are actually linked to past geological events. So they could be earthquakes, erosion events, sedimentation events. And what that means is that you can start to piece together the puzzle of how things occurred, why they occurred, and sort of gain some information, such as things like strain rates, erosion rates, and recurrence intervals for earthquakes. So yeah, so this was the Chalongpu Fault Preservation Park. These 2 pictures being the main entrance here that we were in. It was built in around 2002, and on the actual fault line itself, they measure around 0.01 of a millimeter of displacement, which is pretty crazy, all things considered. You can see around 5 vents in the area, and there's quite a lot of work that actually goes into preserving the fault line. Since there's so much displacement measured, there are issues that, for example, there's water starting to get into the trench itself. There are segments that have collapsed that need to be patched off. So there's a lot of work that goes into it, and this is just one of the few sites that they've actually turned into like a tourist attraction for people to visit over there. So yeah, so as you can see over here, so this was the actual trench itself that you could have seen in the previous picture. So I'll start with the bottom picture. So over there, that's Nick being used as a clinometer. He was having a good time, he enjoyed it. And on the right-hand side, we're just given a bit of an explanation of how they did things, like what was going on, and what like the aim of doing this was. So you can see in that picture, there's a whole structure they built over to protect it from like any weather events, those kind of things. So yeah, that video, right. So that video basically was just this super cool animation that they overlaid, like they projected onto it, on the actual trench itself. And as you can see, it just sort of shows where strata are, and kind of how these events occurred and like what happened, right? So for example, okay, so for example, in the like thing over there, you can see there is some sort of erosion that happened that's removed the first few strata, and then there is an earthquake event, and that obviously caused some vertical offset and a fault form over there. So yeah, we'll be now passing it on to the next section.
Welcome to the Central Range. This is where we see the Moon World and landslide and mitigation techniques. Now, a big part of this trip was establishing connections, and for me, that actually started 2 weeks prior to the trip. I went to the Mine Exchange convention, and I happened to sit down one day at lunch next to the CEO of a Taiwanese engineering company. So after this, I went to Feng Shi, and he actually managed to arrange a meeting with them in Taiwan. The place where they took us was the Badlands, or the Moon World. This is mudstone from the Kutugang Formation, and these were deposited in a shallow marine shelf environment, which means they're very poorly cemented. And on top of being mudstones, they don't really absorb water. So this makes the area very prone to landslides, because they concentrate all the water during the flooding seasons. So what this company does, they're called ACE Geosynthetics, they create these sandbags and grids to reshape the slope. So it gives them the strength to persevere through more flooding and earthquakes, and over time vegetation can grow through them, and it makes a natural hill face. So at the bottom picture right here is what they call the Moon World, because it looks like formations on the moon.
And then we went a little bit east, and we saw the mud volcanoes in the region. Professor Monghan at the University of Maryland, he's on sabbatical, so he wanted to show us this region and tell us more about the mud volcanoes that come up through the mudstone we had just seen. And a way to get these is subsurface fracturing, there's pressure buildup, and then there's degassing of methane and carbon dioxide, which of course we had to light on fire. The mud volcanoes in Taiwan typically align along two features, so they are kind of a result of the tectonics in the area. And then here's a video. And interestingly enough, it was cold when we touched it. All right, and then we went through Yikao Mountain Pass. The word literally means mountain pass. And so originally, there's not that many ways to get from west to east through the mountains, so this is a really critical road. It was originally a pathway for the indigenous people in the region to get across the mountains, and then during Japanese occupation, they expanded it, and now it is known as critical infrastructure, and it's the highest tunnel in Taiwan, so it's kind of cool. But the reason we went there is to see the metamorphic facies. A lot of them are oriented parallel to these very steep slopes, and then we hiked up to the top of it, and it was a really cool, beautiful experience to see that viewpoint.
So one of the key concepts of Taiwan is that metamorphic grade increases from east to west. So now in the central range, we're seeing a mix of slightly more metamorphosed rock. So what we've got passing around is phyllite, and you can see, for those in structural, there's an S2 fabric, and they're class 2 folds. So take a look at that. And there's also a piece of jade that's being passed around. Here, these are marbles, where you can start to see the good foliation. And another interesting part was in this video right here. So we still have geothermal activity happening there. It's still very active.
And then because of these metamorphic features and the phyllite being, and the slate being oriented parallel to slope, it kind of gives you the perfect storm for landslide hazards. Essentially, the Central Range experiences a lot of natural hazards, and like I mentioned, it has critical infrastructure going through it, so it is really detrimental to communities in the area. What you get is there's steep mountains, and then this island is just in particular very seismically active, so over time the earthquakes are going to reduce the strength in the rock, and then you'll get typhoons bringing extreme rainfall. For comparison, Typhoon Morakot had about 2.5 meters, as you can see in this scale bar here, of rainfall. For reference, in my home state of Texas, Hurricane Harvey was half that, so you can imagine how much rain is happening. And then in the pink, it's outlining all of the landslides that happened in right after the monsoon season. And so you trigger a lot of regions. So you get this high elevation, which leads to a lot of roads being washed out, entire communities being destroyed. So the roads are very critical for the island because the military wants to be able to move things across the island whenever. You can see these large-scale landslides, just absolutely massive. One day the bus was broken down, so we walked 6 miles down the road, and we saw more than I'll ever see in my life. It was crazy. And then there's a lot of geoeducation that we'll learn in this region. There was like a little pangolin telling us, don't travel in this area. And I asked Fish, why are there so many cute mascots? And he was like, the Taiwanese are cute people. We like
So as Molly mentioned, the mountains here are kind of tearing themselves apart, and they're coming down pretty quick due to like the rain and earthquakes. So along our trip, we crossed the Southern Cross Island Highway, or Highway 20, and it just reopened about 2 years ago after being closed for 15 years due to Typhoon Morakot, which is crazy that it was closed for 15 whole years. There was 22,000 landslides just from that one typhoon event. And this road is really important to keep open because it's a really key military asset, because it's one of the few ways to get to the east side of the island where a lot of the military infrastructure is. And while we're driving on the east coast, I forgot who mentioned it, but they keep a lot of their jets like in the mountains there. Like they have these big caves they've built to store them in there. So really important to keep these highways open. So So that occurred in 2021, and that was along this highway 20 we were on. It was a result of rockfall that happened during the Morakot typhoon. And this landslide just mobilized all that sediment from this typhoon that was almost 10 years ago. So it's cool that like the interaction between old events and new events, it's just debris is going everywhere. And like events like this don't seem very uncommon in Taiwan, and it's just impressive. The highways through the mountains there are crazy. Like it's a wonder of the world, I think. All right, so on to hazard detection and mitigation. So we stopped. This is the bridge from the video right here. So we stopped right underneath it. You can see here they're building the new bridge above it. And we stopped here and got a quick lecture about how they detected this landslide using a seismic signal. So they used near real-time land quake monitoring system, and it was able to pick up that this landslide is happening and send out a warning. They couldn't get an exact location on the landslide because the seismic signal was a little too low, but it was still good enough to tell people like get out of the way of debris flow paths. So you can see here, the bridge that from the video, like right here, we were standing like right there, here. So you can see this is about 4 miles long, and it all got washed down to here. And it's like, if you're standing on this bridge and you get the warning sent out, it should be enough time to hopefully get off the bridge. And then one of the other big things along their highways is they just have all sort of mitigation techniques everywhere, and they get pretty creative with it, which is pretty cool. So just a lot of these to kind of stop just smaller rocks from rolling down from like the small landslides they seem to have weekly. Those protecting the road as well. And then down here you can just see how quickly the rivers just get totally filled with debris. It kind of is useful for them because they have a pretty big like cement industry there. So they do a lot of, you can kind of see some trucks underneath the bridge, but they'll haul that out to get cement, and it also works to keep bridges clear because the sediment's right all the way up to the bridge. And then kind of the last thing I noticed is they do a really good job there of letting the people know what they're doing and just kind of education, which I thought was really cool. So this was just like a random mountain town I was in, and they had a landslide in like the 90s that was pretty big. So they decided to go in and basically just drop the water table below where the failure surface was, which is just kind of awesome. And they had a lot of just like good signage mentioning like how they're monitoring it, what they're doing. So yeah, it was really cool. It's something I wish the US would do more. And next we'll go to the Eastern Taiwan.
Okay, so I'm one of Carrie Johnson's master's students, and I got given sedimentary basins, so I was really stoked because I was like, we're gonna hammer. She's not here today, I think, so this is very structured on the class. Cool. Okay, so we made it through the Central Range. We got out to the eastern side of Taiwan, and so we have Tatun County down here, and then this is Hualien County up here. What are we looking at regionally? We have the Philippine Sea Plate is subducting to the northwest, going underneath the Eurasian Plate. And then locally, we have the Luzon volcanic arc, and that is being thrust up over Eurasian continental crust. And so that's underplated. And so we have really high strain rates, and we have to accommodate that somehow. And so I get to talk about this basin in here, and this is called the Longitudinal Valley Basin. So this is looking north. On the left side, this is looking south. On the eastern side, we have the Coast Range, and on the west side here, we have the Central Range. And so what are we seeing? A lot of sediment. Why are we seeing that? Because as this plate moves to the northwest, it creates an oblique structure. So we have strike slip, that's sinestral, so that's left lateral. If we're looking across here, that basin is moving to our left, and then it's also being thrust up. And so that's creating a lot of sedimentation coming off these mountains here. And then we also have a core complex over to the west here. And so that core complex creates these normal faults, and through compression and shortening, those normal faults get reactivated as thrust faults. And so we have two masses of land being thrust up into the sky, just raining sand into this basin. And that's why we see all these rivers just come through it. I would love to talk about basin inversion. I don't have time. Wait, sorry, hold on. Thrust faults, we love them. They create these amazing scarps. This is looking east, so this is again in the longitudinal valley. And this is, you're not going to be able to see sinestral slip, but this is being shifted to the left here, to the north, and then it's also being thrust in the sky. And then we actually see this ladder structures. This is looking north. East would be that way. That ladder has been destroyed a little because the right-hand side there has just been pushed up. Okay, now you're good. Okay, cool. Okay, so didn't get a bigger picture of outcrop in here, but this is just west of the longitudinal valley. And so we have this exhumed core complex. We have myelinitic schists. What's up? And we have so really quick. What is going on here? We have sigmoidal porphyroclasts. And so in really high strain, I know a lot of words, really high strain environment, quartz crystals are going to align parallel to that strain direction, and they're going to preserve our strain. So this is not actually the best picture. I should have used another one,
But these tails actually indicate better in another picture that these clasts, they're getting shifted like this. It's going to the left. And that's because this core complex is to the west of that basin. It's preserving that sinestral, that left strike-slip motion. Full picture of schist, diagram of what's happening. You're good to go forward. Cool, okay, craziest thing of it all, we ended up in this town called Qishang, and what is it, Tapo Primary School? We went to an earthquake memorial. The school that is active and has K through 6 students at it, they have this memorial preserving old, like, thrust vaulted ladders and playgrounds and stuff like that. So we pull up, there's like an explanation of what's going on, and at 1:09 in the afternoon, the day we were there was a 5.7 magnitude earthquake. Pretty crazy. I think we were talking about this, and it was like, maybe we're like the only people that have been here visiting this for the purpose of an earthquake, and we felt the earthquake? I don't know. Yeah, so what's happened is offshore, there was both sinestral and thrust slip, resulting in a 5.7 magnitude earthquake. I think it was 50 kilometers, 30 miles away, just northeast of us. It's pretty awesome. You get to feel the P waves kind of moving up and down. We got to feel a little bit S waves side to side. I'm sure my few minutes are up, but.
Thank you so much, Alex. So this is a really similar picture that he showed over here, where I annotated just to really show you, like, this is the fault scarp here, and then this little picture of what happened, why this slide ladder situation got kind of shoved over. In comparison to our Wasatch Fault, this is from Field Methods this semester. So this is a much larger fault scarp with a much smaller slip, so 0.8 to 1.2 millimeters. Compared to 2 to 3 centimeters per year. So kind of insane that we felt an earthquake while we were there. And here's proof.
Yeah, I think it's your question. I asked somebody who studied here a long time, and I didn't get an answer, so I couldn't really tell you. I think what's currently thought is that there might be a whoa! Oh yes!
But Nick was literally.
I think it's
Hello? Okay, and then this is us. Hi. All right.
Yeah. So because of these frequent earthquakes in Taiwan, a drilling project has been initiated in late 2021 to study the fault zone properties. And that drilling project drills boreholes through an active fault zone called the Milun Fault, which ruptured in the 2018 magnitude 6.4 earthquakes that caused the collapse of buildings and hundreds of injuries. So, and this is also one of the first projects in the world that installed optical fiber cables across the fault zones and along the surface. So these optical fiber cables, as you may previously know, it's used for the data communications such as telephone, internet, and the TV services. But recently, it has been used as string meters to record the ground motions. And the usage of these optical fiber cables provides the real-time and in-depth monitoring of ground motion during earthquakes, which allows the seismologists to study the earthquake dynamics, triggers, and possible precursors for earthquake early warning. And these are the findings from the MIDAS project. So they drilled boreholes and they found the fault gouge at around 500 meters at depth. So the fault gouge is clay-like material, which is due to the rock grinding during fault movements. And the similar fault gouge material has been found in San Andreas Fault when the US drilled the borehole through the San Andreas Fault and in this Safford project, which is in early 2000s. And because of the weak fault gouge material, the optical fiber has observed the seismic wave amplifications. So meaning that the material will shake stronger in the fault core compared with the surrounding stronger host rock. And one fun thing we did at the middle side is in the monitor. So that's next section.
Okay, cool. So we're gonna talk a bit about engineering and energy in Taiwan. So there's a lot of geothermal nerds in the trip, but I call dibs. So I can talk about geothermal energy. So there were a lot of really apparent evidence of the geothermal resources in Taiwan. There were lots of hot springs, pools where you could relax in hotels. We ran across some locals sitting with their feet in some hot springs just randomly. And yeah, so there's a big culture around it in Taiwan, but cultural attitudes towards the effects of geothermal resources can have a big impact on whether or not they are extracted, such as in Taiwan, they have one-time culture, so they don't really love extracting geothermal energy, whereas in places like Iceland, their cultures are more mixed with their energy extraction. So as you can see here, you can see down here, there's this big place where there's Lux steaming some corn. And that's actually Qingshui Geothermal Park. Here is the power plant. It was started in the 80s and then discontinued and restarted in 2021. Here's us eating right outside it. We're next to each other. And so the culture and the energy are really, there's a good interplay there, which means that Taiwan is a great place to actually extract geothermal energy. So here's a map of where it's actually most viable. Here is Qingshui, I believe, right there. And Taiwan has a great combination of fractures from frequent earthquakes. It has water from the typhoons, and it has quite a bit of residual heat, not so much from volcanic activity, but more so from the rapid uplift of metamorphic rocks. And I'm sure you're all familiar with the duck belly. This is basically the idea that when we incorporate renewable energy into power grids, there can be this issue in ramping up fast enough because the times, we can't control when most renewable resources are most available, like solar and wind, and they often don't coincide with when we need them the most. Geothermal, on the other hand, is just constantly going, and then it's whether or not we extract the energy and put it onto the grid, so it can ramp up almost instantly like coal, which is great for that base load of power and a big priority for Taiwan right now. Currently, they have about 60 megawatts being generated, and they believe if they extracted all of this, they could get about 40 gigawatts, which is pretty comparable to Utah. Right now, we're at about 70 megawatts, and we believe we can get up to about 50 gigawatts. So yeah, and renewable resources are really important because 1/3 of the pollution in Taiwan actually comes from mainland China, so they have no control over that. So what they can control, it's great to control so that they can keep it as incredibly beautiful as it is right now.
Okay. Wow, how did all the geoengineers get on this slide? That's so crazy. Taipei 101 is a huge landmark in Taipei City. It's called Taipei 101 because of the 101 floors on there. If you see in this picture, we have Gaby and 2 of our amazing Taiwanese students. That purple part at the top is where the observation deck is, which is 1,000 feet taller than the Seattle Space Needle. Just put that out there. It was the tallest building from when it was constructed in 2004 until the Burj Khalifa opened, so that's 6 years that it was the tallest building. It's currently the 11th tallest. But the coolest part is this big orange thing back here. This is their tuned pendulum mass damper. This thing weighs 660 tons, and it has a 1.5 meter radius for it to move, which means that Taipei 101 can withstand 220 kilometer per hour winds. That's one of the biggest risks to a building this tall is this wind sway. Also, more importantly, this is the damper baby, which is the mascot for the damper. Arguably everybody's favorite part. Yeah, Taika 101 is super cool. It's kind of shaped like bamboo on purpose to reflect the cultural aspects of the area. And personally, it was my favorite stop the whole time.
So in terms of culture, Taiwan is a mix of indigenous Taiwanese, Han Taiwanese, Chinese, and Japanese cultures. A few things that Taiwan is known for are things like boba or bubble tea, which I think you guys are probably all familiar with. Taiwan is actually the birthplace of boba tea, so it's very popular there. You can find it all over the place. One of the more common accessories we saw all around Taiwan were these little boba tea cup carriers. They're super cute. The aptly named stinky tofu. This is a really popular street food item all around Taiwan. It's a Chinese cultural influence. It's basically fermented tofu that's served either boiled or fried. And when you're walking down the street, you can smell it long before you can see it. It's very pungent and it's consequently a bit of an acquired taste. I really liked it though. Convenience stores can be found all over Taiwan, but particularly 7-Elevens. This is actually a Japanese cultural influence. The 7-Elevens there are nothing like the ones that we have in the US. They are much, much better. In Japan, they're a lot more like the ones in Japan. The top right images is to show you about how many 7-Elevens you can find in an area of Taipei that's less than 4 square miles. It's quite a few. Likewise, something we learned about from the Taiwanese students, it's a corn puff snack that's developed into this fun little tradition/superstition. It involves placing a bag of green Wi-Fi on top of electronic devices or lab equipment in order to keep it functioning properly. It has to be a green bag because green means go, and Wi-Fi roughly translates to well behaved. This tradition also has a Wikipedia entry, so you know it's legitimate. This is Ray's bag of Wi-Fi that he brought home with him and put on his computer.
It's working great.
Taiwan also has a unique culture surrounding street markets. Night markets and street food. Jiufen Old Street is one that we got to visit early on in our trip. It's a particularly iconic Taiwanese street market. It's more or less positioned on a cliffside, so the walkways are narrow and steep and windy, and they quickly become crowded because it's a very touristy area. The alleys are packed with vendors selling knickknacks and street food, including stinky tofu. The area also has a lot of Japanese influenced architecture because of Japan's 50-year occupation of Taiwan. Not too far away, there's a gold mine. It's now defunct, but this is another reason why Japan was in the area. It's now been turned into a museum dedicated to the mostly British POWs that the Japanese army forced to mine the gold under very poor conditions during World War II. Inside inside the museum, you can find one of the world's largest gold bars. It weighs just under 500 pounds, and it's worth about somewhere between $21 and $22 million US. And they got to touch it.
Totally moved it. Yeah, so most of our group meals consisted of these traditional Taiwanese-style band meal meals, and these are basically large gatherings. A lot of the time, the restaurant was just a large warehouse with tables, and we'd sit around these large tables. They'd bring out large dishes of meats and vegetables. A lot of times they'd have these lazy Susan features, so we could rotate it around and access the food. Historically, people would travel all across Taiwan to come to these large gatherings to eat, and historically they were poor rice farmers, so they would expect nice dishes of meat and vegetables in contrast to the rice that they were regularly eating. And for us, this was a great experience to interact with the Taiwanese students and professors and try some new foods. And here's a quick video of one of the meals we absolutely destroyed. Yeah, and then some more culturally significant locations we visited were Freedom Square and the National Palace Museum. Freedom Square was located in central Taipei. It was just a large area that was built out with various architecture and structures and some gardens. And in the background here, you can see the Chiang Kai-shek Memorial. There's this beautiful pagoda here. and that's dedicated to one of the leaders during the Chinese Civil War. So we got to experience some Chinese and Taiwanese history there. And then the National Palace Museum, here we are in front of it. That was in northern Taipei, kind of near the mountains. And there are a lot of artifacts there brought over during the Chinese Civil War from ancient China. Here's some here. So there's a lot of scroll paintings, armor, weapons from the Bronze Age, some bells from the Bronze Age, and then, of course, the pork stone, which is a piece of jasper carved and dyed to look like raised pork belly. And it really did look like pork. And now, here's a short video from the Taiwanese students. They just wanted to share their experience with us for all you guys. So
Hi, I'm John. This version made you reflect on career growth and lifestyle, like Cass mentioned about the hippie mindset, and might chat with Molly to talk about how students find their internship, and also grants active planning for student exchange, and it really made me realize that how forward think openly and proactively is important for us to our future. Thank you.
Hi, I'm Jen. One of the most favorite interaction for me was some American student who could speak Spanish found out I had a speaking test and had started learning the language. They were very willing to help me and practice with me. It really encouraged me a lot to keep learning. Thank you.
Hi, I'm Jasper.
Hi, I'm Willie. So, spending time in the field with you guys is such a rare and fun experience for me. And at first, I was really shy. So I want to thanks to everyone that came out to talk to me, especially for Nick. Hi, Nick. And also Ray. Hello.
Yeah, Ray, I miss you very much. And I appreciate all the time we get to spend together. It was short, but memorable for sure. And hope to see all of you next time. Maybe in the US.
Yeah, hope you guys can see the figure at the end of the video.
Hi everyone, I'm Christine. And I'm really glad that I can have a chance to join the field trip with some Utah students. During the trip, you guys also sharing about your life and the amazing landscape in Utah. Especially Ted, he also showed us many great photos, which makes me want to visit there. And now I'm in Maryland to join the SSA meeting. And I have decided to have a little trip in Utah after the meeting. So hope can see you guys again there. Bye bye.
Hello, I'm Rebecca. I really enjoy our field trip in Taiwan. What impressed me the most is many Utah students will raise their hands and ask questions after the lectures, which is quite uncommon among Taiwanese students. And also, I was surprised by the supportive and respectful atmosphere when someone shared their opinion. Everyone will listen very carefully and gave the positive feedback. I was also encouraged by some of the students and feel very grateful. Thank you and hope to see you again. Bye bye.
Hi everyone, I'm Dayanand. I'm from Pakistan. Currently I'm doing my master's at NCO. The field trip in Taiwan with all of you guys was truly amazing. It's kind of mix of learning and culture exchange as well. The most important thing that I learned from all of you guys is how supportive and encouraging towards each other and the whole group. And I really enjoyed the trip and I hope to see you all again. Thank you. Bye bye.
Hi, Utah friends, it's Jason. It was a fantastic week for me and I had so many great memories with you guys. One of my favorite parts of the trip was having conversation with you about the experience we had in different parts of the world. And the other favorite part was sharing the food we like in Taiwan with you. Lastly, I want to say good luck with your studies. Happy graduations for some who are graduating. And sincere appreciation for the cause you brought me. See you.
Hi there, this is Wilson from NTU Taiwan. The field trip with you guys was my first time to travel around Taiwan with so many foreign students, with so many different backgrounds and interests. Also, it was my first time to assist a 1 week-long field trip around whole Taiwan. It was very challenging, but I'm very happy to have the chance to introduce Taiwan's geology to you, and I really enjoyed the time with you guys during the trip. The geology was very beautiful, but more importantly, it's my pleasure to have met you guys with so many different personalities. So, thank you guys, and hope your presentation goes really well.
So, as you can see,
Hi, I'm
John. The Taiwanese students really had a large impact on us. It's something we weren't expecting going into it. So one of our goals now is to bring them all to Utah, hopefully in the next couple of years. So sometime around the geology department, if you see fundraising activities for this purpose, please consider donating even just a little bit to bring them here. They'd love to see Utah, and we'd love to see them all again. That concludes our presentation. Yay! For questions, if you have any. I'd love to not be the only one standing. Alex said,
I'll answer it.
Just that one slide. You were called Mr. Bean just on that one slide?
just that one time. Willie was making comparisons between what we all look like and people that they were familiar with from movies, TV shows, and he thought that's what I look like. I also got compared to Woody from Toy Story. Mainly when I was wearing a white brim hat.
So I want to say thank you as department chair. You know, during the week I was just, especially when I heard about you were in an earthquake and that, I was like, so thank you all for coming back. It appeared to me that the amount of geologic education for the public in Taiwan is just amazing. If that's your perspective, you know, how might we get some of that going in geoparks and these museums that are preserving structure and so forth? You know, why do you think that they have that there, and how can we actually expand that to our neck of the woods?
I think something that stood out to me in the way they approached it really had to do with the Chi-Chi earthquake in 1999. Because prior to that, there wasn't very much earthquake education going around. And so as we kind of said a bunch of times, it happened in the middle of the night, which was so lucky. An entire generation of Taiwanese people would have been lost due to that. And so because of the severity of what could have happened, they really took it upon themselves across the country to really educate people about the risks, especially being such a vulnerable place. Kind of as Lux was talking about in the beginning, so many people live in these hazardous areas. And I think that could really be applied here in Utah as we're along the Wasatch Fault. Maybe not as active, but still definitely dangerous. Bringing more attention to building codes. I know that the Fault Line Gardens right off campus is a great educational place, so more of them would be fantastic.
Yeah, I think one of the other things is like the threat from something such as landslides is just so present in their minds, because they experience the threat from those a lot more often than we experience some of the geohazards in our area. Like we don't feel earthquakes super frequently, and so those hazards aren't just present in our minds. But like landslide preparation and the warning systems they set up for that, they get tons of landslides, and so they're always thinking about that and trying to educate about
I will add, it wasn't always like that. Like when we talked to the Center for Disaster Reduction, they did say in the beginning when their office was kind of first starting to really become a thing, it was kind of a fight to get people to care and to get people to realize to understand why they should care. And you know, just adding more education, the more people learn, the more they care, the more they want to fund these kinds of things. And so the more that they got that out there, the more it became a thing.
They all, as I mentioned, they make it really cool. Like the fault preservation site had like this really cool animation on the actual fault that like just made it so clear like how it was going on, which I thought was really cool. And then like a lot of the like that earthquake we felt was like comparable to the Magna earthquake, and they were like, oh, this is another Wednesday for them. So it's just I think it's really prevalent.
Yeah, me? Okay. I was just gonna ask, has this provided or created a lot of jobs in Taiwan, like in all the different fields, like from the volcano monitoring, engineering, and do a lot of people go into these different fields?
We talked a bit to one of the students, Rebecca, about how geology is viewed. According to her, it isn't viewed as like a very good degree to get. We were very shocked by that because I feel like in the US that's not so much the case. So I think that it seems like there were lots of people that we talked to, lots of really knowledgeable people and people working in the field, but there may still be some stigma or like ignorance around it that maybe will change in the future.
Yeah, something else that was pretty interesting, especially about NCER and the culture surrounding earthquakes, is that almost all of the research is centered in academia. So these corporations outside of academia do almost no research, and their primary goal is to fund academia and to fund that research, and then they'll take that and they work on technological applications. It's really interesting if you want to go into seismology research, you would want to stay in academia, whereas if you want to do technological applications and sending out risk maps and conversing with the population, then that's where you want to go into the private sector. So it's a bit different than we have here.
I mean, I can also say a little bit. In Taiwan, the problem, I guess there's not enough like oil or anything that to explore. So most of the people work for hazard related, which is this job, but not like here. Most of the big company are like energy company. But right now there's a strong push to do geothermal and also carbon sequestration. So hopefully that thing will gradually change. Oh, we'll see.
So there's like a barrier, I forgot what it's called, to prevent those rock slides. How strong is that? I'm just curious.
So a lot of the barriers along the highway, the point was just to keep small debris from rolling off. Like it's doing pretty much nothing to stop a big landslide. But I mean, for example, one night, me and Alex were laying in bed, and we should have been asleep, and everything started shaking a little bit. And I was like, wow, this is my first earthquake, this is awesome.
Dude, we were pumped, we were pissed.
So this is the night before we felt the big one. And the next morning I woke up and went for like just a little run up the road, and like it was really small earthquake, but there was like no debris on the road. Like there's way more debris on the road in Colorado and Utah than anywhere else I saw there, which is really impressive. But they also had a lot of like, they would drill into these rock faces and put in things to make it more stable. But a lot of the bigger landslides they monitor pretty closely, and they seem to be more endangering towns than like an active road.
Well, that's something too, and a lot of the time, in the Central Range especially, we're driving or walking along these narrow roads, and then right next to us is this deep gorge with the river. And sometimes we would see large concrete structures that they had previously installed along roads, like pretty much tunnels. They're just completely in the river, rebar sticking out, like massive structures. So they can prevent it pretty well, but what can you do if a large earthquake or landslide happens? It just goes in, falls.
It can seem like they're constantly rebuilding because things are getting torn apart a lot. There's always construction because it's necessary. So, job market, construction. Yeah, cement.
Thank you for attending.
Okay.
Yeah.
Yeah, well. I just want to say quickly that the trip won't be as successful without these great students that we got, and they all participate, all the discussion, and it's just a pleasure to take them to show my hometown and my home. So it's great. Thank you, guys.